Good morning, students. Today we will learn about drying and some of the drying curves. Drying is one of the very crucial operation in chemical engineering. It is widely used in food, pharmaceutical, textile, agriculture, and chemical industries. It is usually the last operation after filtration or maybe crystallization or maybe evaporation. So usually it is the last operation in a operation. Let us first know what is drying. Drying, as you can see on the screen, it is the removal of a relatively small amount of water or moisture content from a wet solid into an unsaturated gas medium. These two things are very important. That relatively small amount of water, relatively small amount of water, and unsaturated gas medium. Because in evaporation also we do the same thing. We remove water content, but in that case we deal with very large quantity of water. But in drying, we remove very small quantities actually. And one of the very important thing is, as I said, unsaturated gas medium, because this is the one which helps us in doing drying. Because if the air is unsaturated, then only it will hold or gain water or maybe water content or moisture content from the wet solid. If the air is saturated, then it will not receive any moisture content from the solid or that wet solid. In industries, we usually perform some basic things in drying. That is, we have, let us assume, a body, and there is water content in it. Maybe some of the water are inside, some of the moisture content are inside the body or inside the bulk of the material, and some will be at the surface. And in almost all of the drying operations, we pass air, that is unsaturated air, through this so that if we have moisture content uh, inside the wet solid or on the surface of the solid, it will move to air. And in almost all cases we use some heated air. So there has to be a heater inside so that we can provide heated air. It's not the normal air. So this is what we do in almost all the drying operations. Of course, depending on the equipment or instrument we use, techniques will be a little bit different, but the fundamental thing is this: we provide heated air, and which is of course unsaturated, because if that air will be saturated, then no drying will happen. Now coming to different drying curves, the first and one of the very easiest one is this moisture content versus time graph. It is normal, it's common that when time will be 0, moisture content will be at maximum, and as the time goes on increasing, the moisture content will gradually decrease. And you can see from this graph, it's a curve, it's not a straight line. And at the end, at this point E, uh, the curve becomes kind of straight beyond this point. So this is known as equilibrium moisture content, and beyond this point we cannot remove moisture content from any wet surface or maybe any wet solid, because this is the maximum moisture content that can be removed. Beyond that we can remove, but we will have to change that unsaturated air medium. Maybe we need a an air with less relative humidity, so that will go beyond this. But in reality, it can never be, it will never touch this line, because air will have moisture content, at least some moisture content at any point of time. It's not that air will have zero relative humidity. That's not possible. So that's why this curve will stay somewhere above this zero level. It can never touch this x-axis, because relative humidity of air will not be zero in any case. So this is the graph of moisture content versus time. Now let us move to the next graph, which is relative humidity versus moisture content. This is also one of the very important graph, because we have these terms here, and we need to clear these terms very much. We need to clear these terms, because these terms are very basic and fundamental whenever we consider drying. So we can see from the curve that initially the moisture content is higher. So initially the moisture content will be higher. Then of course with drying, moisture content will decrease like this, and of course relative humidity will also decrease, because the moisture content are removed from the body. So initially we can see from this graph that here this part is unbound moisture content. So what is unbound moisture content? These are the moisture content which are on the surface of a body, or maybe wet solid. These unbound moisture content are not trapped inside the body. So while removing this, there will be a constant rate period, we can say maybe n. So in this period, initially we will remove the moisture content on the surface of the solid. Then beyond that, whatever moisture content is available, that is bound moisture content. And it's not that we can remove both of them, but we can remove the unbound moisture completely and some portion of the bound moisture content. Bound moisture content are the moisture content which are trapped inside the solid. They are not on the surface. And when we do our drying, okay, let me clear one more thing. This is one thing called free moisture content. This part is the free moisture content. We can only remove the free moisture content. Beyond that, beyond this line, we cannot go further. We can remove maximum of this much moisture content, because when this curve we will start drying, this curve will go like this and it will end at point A. We cannot remove these moistures. We cannot remove this moisture. We can only remove from up to this point, because at this point we will have equilibrium moisture content, which is x star. So beyond this, if we want to remove moisture content, then we maybe we will have to change the air medium, and of course we cannot take it to zero, as the air will have at least some amount of moisture content. It's not that air will completely dry and relative humidity of air will not be zero. So beyond this point we cannot do drying, and drying will stop at this point, and this will be the moisture content of that material after drying. So this is one of the very important graph, and also we need to clear these terms very well, so that we can understand everything in the latter stage actually. Now coming to the next graph or next curve, which is also very important as far as drying is concerned. So we can see this is the curve for drying rate versus moisture content. So as we can see, initially will have higher moisture content, then of course with drying the moisture content will decrease. Also we can see initially we will start from this side, that is from A, B, then C, D, E. So of course over time rate of drying will also decrease because there will be less moisture content over time as we will remove some. So of course rate of drying will decrease over time, and same with moisture content, this will also decrease. Let us first see the first initial part. As I said, in this in all of the drying operations we use heated air mostly. So this is basically the warming period when we pass heated air over that wet solid, so that the temperature of the solid will become equal to the temperature of the drying air in this phase. Once that temperature is achieved at point B, then we will have a constant rate period. That means here the rate is not a function of moisture content. Here the rate is not a function of moisture content, because these are mostly the unbound moisture content, because these are basically available on the surface of the solid. And basically we can imagine if we dip a solid inside a water inside water, so on the surface we will have a lot of water content, and that can be removed easily. So initially up to this point C, we will not have any effect on the rate of drying. This will be constant until we reach this point C, which is known as critical moisture content. This one is XC, critical moisture content. Critical moisture content is the moisture content where the constant rate period ends and this falling rate period starts. Because beyond this point C, when we perform drying, then we remove the unsaturated wet or maybe moisture content part. So here we will remove the moisture content which are basically not above the surface as in case of constant rate drying period, but still on the periphery or maybe outer area of a solid. And in this region dry patches start to form on the solid, and beyond this point D, this D to E, this is also falling rate period, but this one is mostly non-linear. And in this region there is drying from the very core of the solid. So in this phase we will have internal movement of moisture controls. So there will be internal movement of the moisture inside the body in this D to E. And when we reach E, there will be equilibrium moisture content, and as we already know, we cannot remove beyond that. We cannot remove the moisture beyond that, and that is the maximum amount we can remove. So for us in this case, the free moisture content will be this free moisture content, and beyond this we cannot remove. In this region we cannot remove the moisture content. To remove moisture content beyond that, we will have to change the drying medium, we'll have to change the relative humidity of the air, then only we can move further, else the drying will end at this point E. Now one more last curve which is related, kind of related to this one, that is rate of drying versus time. So initially when time will be 0, then that case initially we will have to overcome that initial warming period, as in the previous drying curve we have seen. Then from B to C we will have constant rate period. This one will be constant rate period. Then from C to E we will have falling rate period. So this is how the rate of drying will vary with time. So initially we can assume that is constant up to point C, because this happens for a very low small time. So up to point C is constant when the moisture content from the surface of the solid, wet solid, get removed. Then beyond that, when we perform drying, drying rate will of course decrease, because there will be less moisture content, and so drying rate will be also less. It will get decrease over time. So that's it for drying and drying curve. I hope all of you have understood well. Thank you.